One way to look at and determine the numerical value for the slope of a line here is to think of what this slope of this line means graphically. Let me give you this here. Graphically, the slope of a line tells us how much the line rises or falls along the output axis. That's along here. How much does this line fall or rise? And from left to right, hopefully you agree that's falling. How much it falls or rises along the output axis for every additional unit along the input axis. So for each of these guys here, I've labeled my axes here 0, 1, 2, 3. So for each additional one of these, how much does this fall by, this line? How much does it fall by along here? Well, we can do that. Let's try and grab a point that intersects somewhere on the corner like this guy. So this point would be 3, 5. And what slope gives us here is how much is that value along the output. Sorry, I made I had to erase this over here. Sorry. So how much does this fall by here? These values here along here fall by for each additional input value, or along here, along this axis. So from 3 to 4, where's this line at? Well, at 4 it's right here, and the question is how much did it fall by? How many units did it fall by? Did it fall a whole unit? Did it actually go there? No. Did it fall 2 units? Did it go there? No. It didn't even go 1 unit. It looks like it's a half, maybe just over a half. So that's where I have my 0.6 here. We'll call it 0.6. And why the negative? Well, the negative meaning it fell. So a decrease in this output variable would signify by that negative sign. Okay, so negative 0.6 is the numerical value for this slope, and it doesn't matter where you go. I mean, if you would take this point here, and for each additional from there to there, did it go down a 0.6? Looks like it. And so the slope anywhere along this line is the same, and it has that numerical value, negative 0.6.